Hey, so last night I saw a great video on YouTube from a guy I'm subscribed to because he does great stuff in Fusion. Uh, he did the fretboard video that I will link. Definitely go ahead and watch it. It's near perfect. So I want to try and being grateful that people share some things and not being able to do it sometimes myself. On this one, I really was like really inspired to try and do my own approach on some of his stuff and see if that works for me. And I think it kind of did work out pretty well. So I want to show you my model, but first I want to point out to what problems from his approach I was solving. So let me go back here and do with my own bare sketches. So I have those sketches. The first one is excuse me, let's make this non multi-scale like normal to start with, so it's easier to make some points. The approach he did to put the radius on the fretboard was something like this. He used like this thing, extruded to a thickness, let's say it's 6 millimeters, ended up with like a fretboard blank, and then so what he did, he used something like this, not quite exactly the same, but doesn't matter, to cut through the radius and put radius in it. So extrude, cut all, and there is the fretboard radius, and it looks fine, nothing wrong. Something wrong with it, let's say. Maybe it's not quite obvious at first, but if you go and measure, say, this thickness on this side profile here, it's 5.159 millimeters, and on the other side it's 4.845. so it's different, and it's actually weird because it's thicker at the nut end. Not a big deal, but definitely would bother me with side dot placing, layout stuff. So let's actually go back on Control Z to not mess with the sketches. Yeah, there we are. So what I actually did, I have two more sketches with some profiles. I have a profile here and a profile here, and I loft between them, and that because I use the parameter for this dimension in both sketches, fretboard height, that problem is solved this way. Then I used I have a line here in first sketch that is placed where like 25th fret would be, for the sake of extruding to a face. And then I have let's talk about this line here. This is offset from the end of the fretboard. It's also a parameter, and I use that to cut fretboard, so I can make compensated nut. So I cut some into the fretboard, and then when I make the nut, I chase the good intonation on that side. So there's that extrusion, and there goes the split body command, and then remove some excess bodies. This one doesn't like the way I did it. But what's wrong? I didn't change anything. Never mind. It fails to remove a body. Let's do it this way. Remove it again, and it does it. Never mind. So there's the fretboard. Now someone in comments said, what about compound radius? And I want to talk about compound radius, not the way you make it. It's actually easy to make two different radius profiles and loft between them, and there you have it. But I think there are some things overlooked when it comes to compound radius. Say you have let's put it this way. I'll try and explain my approach on that. So we are all aware that if you have one radius, say 12 inches radius, and you put some strings on it, I will draw only like 1st and 6th and dimension this. Say nut spacing is 35 millimeters. Let's put this, so it's fully constrained, doesn't matter really. And then on the same radius, on normal fretboard, you have a let's see what goes here. Let's measure here. It's like 48 millimeters. So we do like this spacing of 48. So of course there is a difference. There's this. Let's actually do it this way. Let's make those not coincident, rather collinear, these two. And on one side you will see a huge difference. Okay, so that's the difference in spacing. So that is what we are trying to solve. We are trying to bridge this gap. So we do it this way. Let's hide this sketch, create one more. So to solve this, we put 12 inches radius on one side. What was that? 12 inches times 2 inches, yeah. And we make 16 times 2 inches radius. Let's make the same thing for both of them. So we have like 35 here. 35, and then we make the lines, the strings on the heel end, and we dimension that, was it 48, and then say we want to compare those, let's see what we get. So we make these collinear, these two, and sure there is a difference. So we are left with a much smaller gap here. So, but it's still, in my book, it's a problem, because if you are solving a problem, at least solve it, like, you know. So my approach was actually to find out if I go and delete that, and I say I want my neck width at get the nut is 42 millimeters, which is pretty common, or at least close. What's this line doing here? Yeah, it's not coincident with this one. Yeah. Say we have that spacing in a 12-inch radius. Let's actually make this 10 inch times 2. Okay. So now if I want to find out which radius is on this side, I will surely have some trouble doing it. But the way I do it is, being that we are often constrained by hardware choice and actual bridge spacing between the strings, what my approach is I want to know this exact angle between these two lines drawn to a center of this radius. So let's measure, and it says 9.485. So like 9.5, never mind. And when I go and I'll actually put a given dimension so I can go back and refer to it. So the way I did these two is I defined the radius at the nut, which is 12, and then measured what happens here and used that as a guide for this sketch. So I did like this. I made 2 lines from the center, and I put the angle between them of 9.485. Right. So I use that same angle for a larger radius, and I just put in the dimension, which is my bridge spacing plus the 7 millimeters, like I did. So I consider this to be like 35 on the nut, and I have like 52 plus 7 on the bridge. So I have that defined, and one thing missing is the actual radius that will come from that alone. So there we have it fully defined, so they matched. And now we can actually not define but measure our radius at the bridge. So we go ahead and copy this in our calculator, paste. So I had a unit there, paste. So I divide this by 5.4. There we have it. Divided by 2. So we have like 14.04 at the bridge. So it defines itself. I think this is the correct way to do a compound radius. So there's that. I already showed how the model works. It might not be perfect. It's actually not. And I will show you what I have to deal with still. So I mentioned, did I cut here to make a compensated nut? That's fine. I have a parameter string to edge, so I can use the actual string spacing, nut spacing, bridge spacing, and then add string to edge times 2 in those profile sketches as my dimension. But something about that part doesn't quite work out. Let me show you. So this actually looks fine. Did I project this? Yeah. So I have fret slots projected to the surface for CNC work, for trace operations. And if I go in and make this multi-scale, but go to a little bit more extreme, say 750, the model solves fine, but there is one problem. So my string to edge should be 3.5, but it's not. It's not even consistent. It's different. And I cannot figure out what's wrong with it. So if anyone is interested in participating and helping, I can share this project, so you can try to figure out what's wrong. So it's not very consistent. It's not too bad on the bass side, it's actually quite good, but on the treble side it's just falling apart. Someone won't be sleeping tonight. So anyway, that would be like my thought on the main point was this about compound radius. So you cannot just say 12 to 16 or 9 to 1000 or whatever. You have to understand the problem and find a way to solve